La siguiente conferencia la va a impartir Melody Jackson. Ella es la gerente de Ciencias de la Construcción de GAF en el sureste de Estados Unidos. Tiene 11 años de experiencia en la industria de la AEC y 7 años en Derecho de la Construcción. Es escritora de especificaciones independiente con más de 5 años de experiencia. Además, tiene 4 años de experiencia como representante arquitectónica en la industria de techos comerciales. Posee una licenciatura en Ingeniería Química y una maestría en Arquitectura de la Universidad de Houston. Activa en IEA, IBEC y CSI, con 6 años en la Junta Directiva de CSI Houston, 2 términos como tesorera y actualmente es vicepresidenta de Publicaciones y Servicio Público. Es miembro fundadora del capítulo de National Women in Roofing en Houston y mentora en ACE, brindando oportunidades a estudiantes de bachillerato interesados en arquitectura, construcción e ingeniería. Deme la bienvenida a Melody Jackson.
Okay, we still have a few people out, but they will wander in. Thank you for coming back after the break. I am with GAF, which is a major manufacturer of roofing. GAF is part of Standard Industries. Standard Industries worldwide is the largest roofing and waterproofing company in the world. In the United States, GAF is on more roofs commercially and residentially than any other manufacturer. Today we'll be talking about wind design for roofs. This is a very timely topic considering we just had Hurricane Otis that came in on the western coast of Mexico. How many of you have had hurricane damage to your home or your business? Anyone? Am I the only one? I have a beach house on North Padre Island near Corpus Christi, and I had flood damage and wind damage. I lost my roof from Hurricane Harvey. So this is a topic that has impacted me personally. I've done a lot of hurricane area projects as a spec writer, so this is kind of a topic that's very close to my heart. So we'll be talking about wind design for roofs today. Oh, over here. Got it. So today we'll identify and discuss foundational elements involved in determining wind loads acting on a building. So we have various loading things to look at. We'll learn the difference between the load side and the resistance side, and we'll understand how each is presented within the roof industry. We'll evaluate roof zone layouts and their effect on the installed roof system, and we'll explain recent changes and the impact of new information from FN Loss Prevention Data Sheets 128 and 129. These are really important documents for us. And we'll talk a little bit about edge metal and how important that is for designing a roof system that will withstand these hurricane uplift conditions. So first of all, we'll just look at a simple building here, and we'll see as the building approaches, it will go up and over the roof, and that will cause a negative pressure, a negative design pressure, pulling our roof up and off of our building. If we have a breach in the building envelope, we lose a door, the glass is blown out of a building, we have a large missile that's destroyed our windows, we will have internal pressurization of the building, and now we have positive loading pushing the roof off from the inside. So we have various mechanisms to lose our roof. So first we'll talk about wind uplift on our load side. Here is a sample building, and we'll refer back to this all the way through the presentation today. I've made a few assumptions. It's a rectangle. It's very simple. I don't see any rooftop equipment or penetrations. If every roof like that was like that, it'd be easy, right? But it's not. We have high wind speed, 120. Hurricane Otis was much, much more. This is exposure C. This is a pretty flat terrain, so this might be the biggest object in the area, and it's enclosed. So we'll go over later about what a partially enclosed or an enclosed building means. And this project has no parapet. Whoops. Okay, so we're going to be using the FM Roof Nav calculator today, and we'll work our way through that and see how this can help us design our system. And the first thing we want to look at, and you can see the blue box on the top, is our ratings calculator. This will calculate our wind uplift rating for us. Our wind uplift rating indicates how much wind uplift pressure a roof assembly can resist. This is not just the roof membrane. This is our whole assembly. It's measured in pounds per square foot, and we'll have ratings spanning from 60 to 990, and this is in 15 PSF increments. So this will be really important to remember later when I talk about going from a 1-70 rated system to a 1-85. So you can see that 15 PSF increment. The ratings are used to determine what FM-approved assemblies can be used in a given roof area. So first we will click on the little wind tab, and what this will do for us is give us a rating. But first we need to think about the load side variables that will help us determine that rating. We have surface roughness, we have the location of our building, and we have the basic wind speed for that location. We have the exposure classification, and then of course we have the roof dimensions, which are important. So first we'll look at the surface roughness. So on this surface roughness category, it's roughly defined. This is not the strict definition, but we have roughness B. This is urban and suburban areas like Mexico City or the suburbs. It could be a wooded terrain with lots of obstructions, but basically the wind just doesn't go past. There are a lot of obstructions. Surface roughness C is pretty open terrain. The things that are in the way are generally less than 30 feet. So this pretty flat open country. And surface roughness D are water surfaces or flat, totally unobstructed areas. So we also need to look specifically at the location of our building and the basic wind speed. And FM Roof Nav will help us determine that. So what we will do is after we click on wind speed, we can enter Mexico East, Mexico West. There are several locations you can select. For this sample, I selected East. And then you click Go, and magically Roof Nav will give you a wind map for the eastern coast of Mexico. This is our LPDS 128. This is going to be really golden information for you. So we will take this information and use it later. But there's another way to do this. We could enter the miles per hour if we already know the wind speed at our location, or if we want to increase the specifications to a higher level, we can select a higher anticipated wind speed than we would normally see in that area. You need to keep in mind that your specifications for your project are minimum standards. So another way to think about what minimum standards means, it's your best, worst building. So for something like an essential facility, like a hospital or a police station or fire station that need to remain in operation during a storm, you want to design to a higher level. So here you could put in the specific wind speed that you have in mind. And we will always check that little blue box there. Location is a tropical cyclone prone region when we're designing for hurricane uplift. So we need to also think about our exposure classification. What does that mean? It means that, this is pretty fine print, in a tropical storm prone area where we think that we will lose windows and doors, for example, in a home, their houses are usually designed to a lower standard compared to commercial buildings. So we will probably lose a window. We have flying missiles, we have rocks, we have lawn furniture that blows around. We have a 4x4 could go through your roof or window. So we will consider those partially enclosed if we've designed the building to very high standards so that our openings, our doors, our windows, big roll-up doors are missile D impact resistant, then we could consider that an enclosed building. And this will make a big difference in getting to our end result. So for this sample, I have selected enclosed buildings because we're designing a wonderful building that should withstand a hurricane. And then we have to consider our roof area dimensions. These are very important because this will change a lot of things on your project, including fastener spacing. Can't say that. So our next step would be to enter our roof area dimensions, and you'll have these pop-up boxes on the right so that you can enter your dimensions. Super simple. And what you will get is your wind uplift is calculated, and you get a sheet that looks like this on the right. I'm going to look at that in two parts so that you can actually read it. So the first part on the top just gives you back the information that you just entered. So this is a real easy way to check your work and make sure you entered the right numbers. At the bottom, you will see your wind pressures in PSF that RoofNav has calculated for you. So for zone 3, which is our corners, that's where we have the highest wind uplift. We have 138 PSF. So is that the number we need? No. RoofNav has applied a safety factor of 2 and has determined that we need a 1-285 system. If you want to design to a higher standard, you could go up 15 more PSF, that's our 15 increments, and we could do a 1-300 system. So here we're looking at our roof zones. This is very simple in a rectangular shaped building, but what if you have an L-shaped building? What if your building is shaped like a Z or any other crazy thing that an architect could come up with? And most of the time they will come up with something unusual. Then a lot of things change. So your outside corners will always be zone 3. If it's an inside corner, it's not. It can get very convoluted. So there's ways to dive deeper into that, but I did not have time today. But just keep that in mind that that will change. Our zone 2 is the perimeter of the building, and then zone 1 is the main field of the roof. But our biggest takeaway when we look at that is that RoofNav applies a safety factor of 2, like I said before. So we go from the 138 PSF in this bottom corner on zone 3, and we multiply that times 2, and then we need to jump up in the 15 increments. So we end up with a 1-285 rating. So now what do we do with that? Before we go further, we need to look at the wind uplift on the resistance side. And so where do I find this wind rated system? Okay, that's the question. Like, where do I go next? There are various listing agencies that have roof systems that have been approved for the uplift that you have determined you need for your project. So we've been using RoofNav, but a lot of people are very familiar with Miami-Dade. They were really the first to come up with these standards that we want to adhere to, sort of the gold standard. I live in Houston, Texas, so when I was writing specifications full-time, I would always refer to Texas Department of Insurance, which also has a lot of ratings, so that's another way to do it. All of these are great listing agencies, but what you need to be careful about is that some of them apply the safety factor of 2 and some of them do not. So when you're looking at an FM rated system, you will see that the safety factor of 2 has been applied. We saw that before in that calculation, multiplying times 2. If you look at Florida Building Code Miami-Dade or Texas Department of Insurance, the safety factor of 2 is not included in that. So you have to be mindful of which listing agency you're using and exactly what information you're getting. So let's keep going with our RoofNav and select our actual roof system. So here we are. We're back at we have our data we got on the first part of this presentation, and we're using the safety factor of 2 since it's roof nav. So we will keep going. Now we can select assembly search. That's that red box at the top. So we can get rated assemblies. If you just click that button, you get 1.1 million approved listings. So where do you go from there? There's still a lot of work to be done, and we can narrow that down. So what we will do is we will go to assembly search, and we will fill this out with all of the information rated to our project. So for example, here we can select our roof system, and the pull down on the right says we can have a standing seam roof, we can have a single ply system, we can have a multi-ply system like a mod bit or an APP mod bit, a liquid applied system, and we heard about all those different systems in our last presentation on vegetated roof, right? So then we're going to think about the application. Is this a re-roof or is this a new roof? All of these things matter. We're going to pick whether we want it to be a mechanically attached roof or whether we would like an adhered system. It also had the choice of none, which I don't understand. We're going to select our deck type. If we know it's a metal deck, wood deck, concrete, for example, we'll make our selections here. We'll enter the slope. Here, it gets very specific, so it's easy to select the slope for your project. And so now we have our assembly characteristics. These are all the selections we just made. So on our wind uplift, our ratings are from 60 to 990. And we calculated that, right? So we can enter that number. Here's where we can enter our internal and exterior fire protection ratings. So if we want a Class A rating, we can select it there. And we can select whether we're in a hail region or not. So you don't have to select that at all. But very severe hail is the VSH, severe hail. And so now we have all of these things I discussed have already been selected. And this is going to help us a lot because this is narrowing down our search to a little over 17,000 approved listings. So now we can go to the specifications tab and add even more information, which will bring this down to a smaller number because no one wants to look through 17,000 listings. So what we'll do is we'll look first at the covers. It's called covers, but basically this is our waterproofing membrane for our system. And I have selected single ply just for the example. And then we will enter details about this single ply roof that we have selected. So here I have selected a company. So if you know you like GAF, you enter that. If you like Suprema, you enter that. If you like Johns Manville, you enter that, and this will help you narrow it down. Just by selecting GAF, we went from 17,000 choices to 842 for GAF alone. And the other manufacturers will similarly have a lot of choices. Now I'm narrowing my selection even more. I'm going from single ply membrane. I want a TPO membrane, because I'm a TPO fan. I'm going to enter the thickness desired. So on this sample, it's a 60 mil membrane. If you're designing for an essential facility, I would probably go to an 80 mil membrane. Beef up the system a little bit. And now this has narrowed us down to 24 approval listings, but we can do even better than that. We can start selecting other parts of the assembly, like our cover board. You always want a cover board. This is a lot of controversy. A lot of people say, oh, we don't need it. We install roofs without a cover board all the time. The cover board is really going to help you in the high uplift situations and in hail situations. Cover board's very, very essential in my opinion. We can select the manufacturer of the cover board. That narrows it down even more. And so now we are down to only 2 systems that are approved for the uplift that we entered earlier. So now we have an assembly number. This is what we're looking for. So with that assembly number, you see that on the right, we can go on and we can enter even more information. So when we start making these selections, over on the far right side, we'll see the little view button. And when you click that button, you will get more information about the product selection you have made. So for example, here for the single ply GAF membrane, we see that the membrane itself is called Everguard TPO. It's a 60 mil. We entered that, polyester reinforcement. So just a little extra information about the selections you have made. So here we're looking at the cover board. We narrowed it down to a GAF manufactured cover board. And so that's the little click on the view. It gives you that info. So now we can go a little further. We can, going down to the cover board, the view gives us, when we select polyiso insulation, we get this one. Sorry. And we continue making selections based on the board stock, the cover board, the insulation. And we are now thinking about this as an entire system, not just the waterproofing membrane itself for the roof. So here we are going to select on our securement to get a fastening pattern for our system. So we're looking at a contributory area of 4 square feet. And what this looks like, if you do it in plan, in zone 2, we will have this fastener pattern. And we'll come back to that, and we'll see how that changes in the different zones on our roof. So we can add more information. The owner may have specific products or manufacturers that they want. So, or the architect may be specifying this. So all of these things are taken into consideration. You can add more and more info if you want to. So one thing to keep in mind is the RoofNav ratings calculator determines our designed wind pressure per the LPDS 128. And remember that RoofNav always applies that safety factor of 2. When you look at RoofNav's wind uplift ratings, they're determined by actual physical testing, and these increase in increments of 15 again, so a 1-60, 1-75, 1-90 will not have the safety factor built in. So this gets a little confusing. You really need to know exactly where you're at in this process. So a 1-60 rating means that this roof will fail somewhere between 60 and 74 PSF, because 1-75 would be our next level up, right? So on our assembly search, if we just type in our assembly number, you will get something that looks like this. So we'll have a 60. That did not include our safety factor. If you look at the bottom 2 sections of this diagram, you'll see that the wind pressure calculations do not include our safety factor, and that our wind uplift ratings do include the safety factor of 2. And I'm repeating this over and over because it's really important to distinguish between these 2 numbers. So for FM in a nutshell, our property loss prevention data sheet 128 walks us through our design procedure. 129 has installation criteria for us, fastener patterns and so forth. And the FM 4474 is our testing procedure that will give us the rating of the system, the 1-60, the 1-75, the 1-90, for example. So now that we have calculated this for only one of those zones, we will want to probably go back and calculate that for each of our roof zones, for zone 1 in the field, zone 2 in the perimeter, or zone 3 in our corners. So we can do it that way, although there is a prescriptive method we can use that's defined in the LPDS 1-29, and this is a very widely accepted practice to do it this way. Zone 2 and zone 3 are calculated from our zone 1 values. So for example, we have determined zone 1 prime, 1, 2, and 3 in the column on the left. That's our design wind pressure, our design wind uplift pressures, and that includes our safety factor of 2. Our roof nav wind uplift rated assemblies are seen on the right. And you can see, for example, on zone 3, 116, we're going to round that up to 1-120 because we're looking at it in increments of 15. So we'll always round up. So in zone 1, for example, we're looking at a 1-175 system. Our extrapolations are always taken from zone 1, not zone 1 prime. So here's the prescriptive enhancement that LPDS 129 tells us we can have. We can use the number of fasteners from zone 2 and increase that by 50% to get for zone 2, we can increase zone 1 by 50%. Sorry about that. And in zone 3, we'll be looking at 1 fastener per square foot. And we always want to round up. So if you get a number that's got a half or a 0.25, you'll always want to round up there. So let's look at an example here. We've got a mechanically fastened roof. We've got a 1-105 uplift rating, and for that one, we need 1 fastener per plate per 2 square feet, or 16 fasteners for our 4x8 board in zone 1. So what will we use in zone 1 prime, zone 2, and zone 3? Let's take a look at that. So here's what we've got. We're going to start with our zone 1 number, 16 fasteners per 4x8 board. So we'll use that same value in zone 1, which is the first column. We'll multiply times 1.5 to get zone 2. And then for zone 3, we will have 1 fastener per square foot. So this is how our fasteners will be distributed on our roof. Now, this is the fastening pattern, for example, for your first layer of polyiso. It's best to have more than 1 layer of polyiso where you can stagger the joints and avoid that thermal and moisture infiltration that can occur if it's just 1 layer of polyiso. And then above that, we're going to have all adhered layers. So let's talk for a moment about edge metal. This will be considered zone 4 and 5. Zone 4, for example, is the face of the building. So our vertical surface on the building, same with zone 5, and those are different parts of the building. Here's what we don't want to see. I see huge pieces of roof that just came off. It's not that the roof was damaged, but it's just blown off of the roof. And we can avoid some of these problems by having a good edge metal selection. So the 2018 International Building Code prescribes ES1 testing for edge metal. And you can see on the RE1, RE2, and RE3 examples the direction of the testing. So on RE1, which is for ballasted and mechanically attached membrane systems, the pressure is pulling down on this edge metal in the test. On the horizontal component, when it's 4 inches or less, we're pulling away from the building, perpendicular to the face of the building. And for our coping caps, you can see that it's pulled away from the face and it's also pulled up. A lot of people don't know about this. So I would recommend that you take a little time and dig into edge metal and what that means for you. Oh, let me go back one slide. So it's really important to remember that these are tested edge metals. A field fabricator can bend metal that may look exactly like this profile, but it is not a tested ES1 edge metal. So you really want to try to get this directly from a manufacturer that has passed all of the testing requirements for ES1, not just something that looks like the exact profile. Because the ES1, when you buy those products from a manufacturer, they also include all of the fasteners. It's usually pre-drilled fastening patterns all the way down the metal, and this is all used in this uplift rating that they get for these particular profiles. So here are some sources for doing a little more digging on that. So to wrap it up, and I'm early today, so our key takeaways are that our load is less than our capacity. So our design pressures will always be less than the capacity on our rated assemblies. We can increase those values for essential facilities, for example. We talked about how to use FM approvals and our RoofNav system. I would encourage you all to get on RoofNav and just walk your way through this. It's pretty simple. If you need to contact me, if you have problems with how to walk through it, just catch me after the presentation and give me your card and I will send you some more information. It's a lot to cover in a short amount of time. So we talked about our load side, which was the wind going over our roof, pulling our roof up. Those are negative pressures. So when you look at that, you need to not be surprised that it says it's a negative number. So our miles per hour, our wind speed is not the same as the design wind pressures because those are pounds per square foot. We also need to look at the resistance side, which is the interior, and this internal pressurization of our buildings when we lose a door or window or all of the above will push the roof up from the bottom side. So we have pressures from that direction as well. We talked about the different roof zones and how to navigate that, how to calculate fastener patterns for each of those zones. I would encourage you to look up more data on a sort of a convoluted roof system and how complicated that can get on determining whether you need zone 3, which is an inside corner. And we talked, of course, about our edge metal and how important that is in helping to keep the roof on. So we need to really be thinking about this in terms of systems. So it's not just the waterproofing membrane, our single-ply membrane, for example, PVC, we're putting on a building. It's our insulation, it's our cover board, it's our securement method, it's our edge metal, and all of these are combined to have a system that will hopefully resist these hurricane uplift forces. So GAF offers office hours, and we solve tricky problems, tricky detailing questions, just about anything. If you're interested in that, you can get with me at some point today. We have that every Friday from 12 to 1, or we can set up a specific time, and that's to meet with someone on my team. Usually includes also the salespeople because they have very specific product knowledge related to specific locations, so they can help a lot, but we solve a lot of really crazy problems. And here again, Melody Jackson, in case you've forgotten my name. So that's it for today.
Hay preguntas para...
Hello.
Oh, I'm sorry.
Great presentation. I had a question. We see a lot of variation on that edge metal when it's fabricated on those copings. How is FM, when they insure a building, do they require the testing, and so it's like should have, or are they a little bit, more open? Or?
Yeah, FM doesn't have specific requirements related to that edge metal, and we can see as we walked through all of the steps to design our system, we really never had the box to check ES1 rated edge metal, but I would encourage you to look into that very heavily. The problem with, for example, roll forming on site is these profiles can be bent, but the metal itself may differ from an ES1 rated edge metal. Again, they are pre-punched with places to use the fastener, so there's no guesswork in the field, and also it's the correct size fastener, because that fastener is part of the testing for this ES1 system. A lot of times when you do the roll forming in the field, the installer goes and grabs whatever fasteners they have in their truck, and that's where things can start to fall apart. So you got to be very careful here. This ES1 rating is for these specific edge metal profiles, not for the shop in general. So it's the specific product, the specific testing for that system.
Okay, thank you so much, Melody.
Thank you.
Un aplauso.